Okay, so today we are going to just be taking a quick look and making sure that we're all okay and our brains are spinning again since summer break, and we remember our basic rules with solving equations. Okay, so our next unit is all about solving equations. Hopefully, as we go through the majority of the unit, it's review. Okay, but I am going to be asking you to sort of stretch your brain a little bit farther, think about it in a little bit of a more in-depth way, and making sure that we actually understand what we're doing and not just circling a variable, drawing a line, and getting an answer because that's what my teacher told me to do. Okay, the first thing that we need to know when we are solving equations is that there are inverse operations, right? We talked about that inverse property. Okay, and our inverse operations say that we can undo addition with subtraction and vice versa. We can undo subtraction with addition. And we can undo multiplication with division, and vice versa. We can undo division with multiplication. I usually get students across the board as we're moving forward through here. Some of my students are like, oh my gosh, we're starting here. I've done this 100 times. Great, you're gonna have a couple easy days, just like they're easy days. Count as a win. Okay, and then for some of my students, they're coming from courses that they're like, wow, we haven't really ever talked about this before. Okay, so we're starting at the beginning here. Okay, and what these inverse operations tell us is that if we have an equation, what does an equation always have to have in it?
Equal sign.
An equal sign. So everything that we're looking at has an equal sign. Okay, if we have an equation and we have an unknown number, how do we represent an unknown number? With a variable. So if we have an equation, so we see an equal sign, and we have a variable, we can use inverse operations to decide what that variable equals. I mean, very basic. X plus 7 equals 12. Now, you might be grumpy at me for this, but I'm not changing my mind, so you can moan and groan all you want, but it's not changing. You need to show your work every single time you solve an equation. For a couple reasons. A, the equations are not always going to be this simple. Okay, and some of my students just look at this problem and say, oh, x equals 5. Because I know that 7 plus 5 is 12. Okay, but when we solve an equation, it's important that we understand a bigger concept that's happening. Okay, we want to use some inverse operations to create an equivalent representation of this exact same thing. Okay, so when we look at this, we should be able to A, identify our variable. What's our variable up here? X. And hopefully at some point we've heard something is equivalent if whatever we do to one side, we also do to the other. What does the word equivalent mean? Equal, right? So if I have a scale and I have 5 pounds on each side, if I add 1 pound to one side, what do I have to do to keep the scale balanced? Add 1 pound to the other side. Why? Because it creates the same equivalency, it just looks different. Right? So I can write 4 lots of different ways. 4 is 4, 4 is 16 over 4. Right? It's sort of that same idea. I'm creating this same thing, but I'm just going to make it look different. Okay, so to do that, I'm going to look in front of the 7 because that's the number I need to get rid of. What operation is happening in front of that 7? Addition. How do we undo addition? Subtraction. Okay, and whatever we do on one side of the equal sign, we also have to do on the other side of the equal sign. Okay, so if I write it over here on the left-hand side, I also have to write it over here on the right-hand side. Why? Because if I add 1 pound to one side of the scale, I have to add 1 pound to the other side of the scale. Okay, so we talked about this with our properties. 7 and -7 give us what? 0. That's like the identity, makes them go away. Okay, so what do I have left over here? X. So I'm going to bring that down. If you're not good at mental math, I don't care. You can pick up your calculator and put in 12 minus 7 equals. And what does it tell us? 5. So we get an answer of x equals 5. Miss Student's like, oh, job, Mrs. Beginning, this is so boring. But what happens if we say this thing? My students start to go, huh?
Wouldn't you add 4?
Well, we need to talk about that. Okay, because sometimes, I mean, there's only 2 options to pick from here. My students are pretty confident that they should be adding or subtracting. But we need to make sure we know why. Okay, it's really important that we understand the why at this point. And the reason why we need to understand the why is because, right, maybe it was okay in middle school to get by just sort of doing whatever your teacher told you to do. But as you get in further and further math classes, it's not going to just be solving an equation. You're going to have to understand why you can do that to make a balanced equation in chemistry. Okay? So if we look at this, we have 2 choices. And I kind of want to get a feel because my students sort of come into me with different things. How many of you say you have been taught to turn this into 1 symbol? If you see 2 symbols, you turn it into 1. A couple of us, and we would just write this as a subtraction sign. How many of us say, I've never been taught to look at this one and I just think I know what to do? Okay, so that leaves the rest of us. Okay, so if you've been taught to change this into 1 symbol and turn this into a subtraction sign, that's fine. If these 2 symbols are the opposite sign, that can always be condensed down to 1 subtraction sign. I'm going to be honest, I've kind of watched my students over the years, and it is kind of a truth with mathematicians. My college professor used to tell me all the time, the best mathematician is a lazy mathematician. Don't make extra work for yourself if it's not needed. So if you understand the concept, we don't really have to do another step of rewriting this. What's our variable? What's the number that we want to get rid of? -4. So we'll look in front of the -4, and what operation do we see? Addition. How do we undo addition? Subtraction. So we will subtract -4. Right? We're changing the operation. We're keeping the number the same. And the reality is, that's exactly what I did right here because this was a +7, right? I just didn't write the positive because we assume we know it. So I'm changing the operation and I'm keeping the sign of the number the same. This is the more obvious one where my students will then go, well, duh, Mrs. McKinney, subtracting a negative is really just adding. Right? Most of us know that, adding the opposite. So if the signs are the same sign, right, a negative and a negative, or a subtraction and a negative, if they're same sign, that's really adding. So if you want to change that to adding 4, you know that that's adding 4, that's fine. If you literally just say, I don't know, I'm just going to follow the steps, and so I'm going to write down here that I'm subtracting -4, great news, because you could pick up your calculator and you could do -12 minus -4 equals, and what would you get?
-8. Right.
Oh, -8. You said -8. I wasn't hearing an 8 there in my brain. Okay, so we'll get y equals -8. Sorry, my brain was slow to catch up to what I was hearing. Yes, Brady?
I think it's just simpler for us to just instead of like
Wait, hang on. I'm going to cut you off. So when you say it's simpler for us, what you're really saying is it's simpler for me. What's sometimes simpler for you isn't going to be simpler for everyone else.
Sure.
Okay? So this is where we start to really get into multiple options. And you'll hear me say, it's okay to pick a different option. So what is simplest to you might not be simplest to your neighbor, and that's okay. Yes?
So if like on a test like that problem showed up, would you count points off or like take like a point off if we put plus negative instead of doing like the minus negative or the plus negative?
No, if you just put a +4 here and a +4 here, great.
Okay.
You knew that was subtraction, you put addition. Awesome, no problem. Okay, the reason why this is the one I actually write up here is because most of my students who go right to the +4 already knew that and they don't need to see any more with it. Okay, because then it's also pretty common that if we see this as a problem, this is the way more common one that my students look at, and they see this double negative, and what does that become? A positive. That's the one my students are confident on. Right? Subtracting a negative, they're like, oh, no problem. That's adding the opposite. That I can turn into addition. Now, I am going to say this. How many of you want to rewrite this with that W on the left-hand side? Do I have any of you in here? Yep, I veto. No more. Cannot be done. And my students will say, ugh, but I got to do it in middle school. Yeah, you're right. But it doesn't work long term, and it's not going to work with everything we're doing. So we need to start practicing it now. So keep that W where it's at. Otherwise, when we get to literal equations and solving for y, and whew, you're going to be really overwhelmed. So we're going to try and leave this here. How many of you are my X lovers? Where are my X lovers and you want to turn this into an X because you love X? Don't do that. That's a veto as well. You type the wrong letter on state testing, they count it wrong. Yep. Okay, so you've got to, we don't want to know what X is. We want to know what W is. That's the paying attention to detail process standard. Okay, so how do we undo adding 7? Subtracting 7. 14 minus 7 is? Now, if when you're here at the end, you want to rewrite this as W equals 7, that's okay. Realize this is life-changing and I'm crushing all your worlds right now. Oh. How about this one? What's our variable up here? I promise I'm watching the clock, guys. We got time. What's our variable up here? B. What operation is holding 4 and B together? Multiplication. How do we undo multiplication? Division. So if I divide on one side, I have to divide on the other. Notice I didn't draw the line this time. You can always draw the line down the equal sign, but we don't have to. What is 21 divided by 4?
5.
Oh, decimal lovers unite. I mean, it's reduced. If you want to write it as a decimal, you can. If you want to write it as a mixed number, you can. No rounding. Just like the rules we talked about with our calculators. Nope, we're still going, guys. I swear I'm watching the clock. How about this one? What are we going to do? We undo division with multiplication. We okay there? How many of you want to write it here? Do I have some of you who do that? Some of you made me funny faces with where I wrote it. If you write it here underneath and put ×3 like this, I'm okay with that too. As long as we're recognizing that this cancels each other out. And we get x equals 15. Here is the deal. Homework is from your